Morning, everybody. So, as Joe and Sam said, I'm here to present. I think I know what you're talking about, but I'm not sure. So, I'm Jen. I'm a self-taught web developer. And I just watched Moana, so I made this GIF. Really empathized with the feeling. I currently work as a software engineer at Eventbrite. And you might know me, particularly if you're from the US, as the creator of Human Wasteland, also known as the poop map of San Francisco. If you don't know what that is, you can feel free to ask me after. You might also know me from this project called Developers, which is a dedication to Mr. Steve Ballmer. So all of this is just a long-winded way of saying that I write code for a living. A quick note, the very first conference I ever spoke at was a PHP conference, so I have a lot of love for PHP. So before I get started, some disclaimers. There are going to be a lot of animated GIFs in this talk, and there might be some errors. So you might be a little bit like, wait a minute, hold up. But before you get a little bit more like this, let's talk about it. But we can talk about it after this talk. So let's go. As I said, I'm a developer, software engineer, programmer, or whatever else you want to call me. So some days when I look at my computer, I feel a lot like this. I don't even know what the hell this means. And sometimes when I'm in conversations with other developers, I feel a lot like this. I'm like, wait, what? What did they just say? I think I know what they're talking about, but I'm not quite sure. So Phil Carlton once said that there are two hard things in computer science: cache and validation and naming things. And we can see that in the various vocabulary that we use to describe things in computer science and web development. So here's just a smattering of words that really confused and still confuse me. So sometimes when I'm in conversations with other people, they'll use these words, and I ask, oh, can you tell me what that means? I think I know what you're talking about, but I'm not quite sure. And a lot of times when I ask that question, I get a look like this, and that makes me feel like this. So as I said, there are some super crazy words that are really confusing in computer science, and we use them all the time in web development. So I'm here today to explain some of the interesting history behind these terms and why they're so confusing. So you can feel a little bit less like Urkel and just a little bit more like Brent Rambo. All right, so let's get started. Parameter versus argument. What is the difference, and is there one? So you'll see by searching on Google, it's quite a popular question. It's the third result down, argument parameter difference. So I have a function here. It's written in JavaScript. And you'll see at the top it's called shark. Inside shark, there's something being fed in called side. And then at the very last line of this function, or I call this function with a string left. So how many people think that side is the parameter? Raise your hand. Okay, some people. And how many people think it's the string left in the function call? Raise your hand. All right, some people. Well, I'm not going to tell you yet, but let's keep going. All right, so parameter in the online etymology dictionary. Etymology is basically the history of words. So the online etymology dictionary says that a parameter is a measurable factor which helps to define a particular system. And it's like, okay, that kind of makes sense. So parameter probably helps maybe define the function. However, when I look up argument, all I can find is information about arguing with people. So it's like, okay, maybe I'll check out Wikipedia and see what they have to say. And what they say is that the term parameter, sometimes called the formal parameter, is often used to refer to a variable as found in the function definition, while argument, sometimes called the actual parameter, refers to the actual input passed. And I think because we're all developers, we probably kind of get a sense of which one is the parameter and which one is the argument. But then I was like, why don't we use formal and actual parameter anymore? And in order to explain that, we kind of have to go down the rabbit hole. So it all starts with math. So what does Wikipedia have to say about math? They say that a function definition can also contain parameters, but unlike variables, parameters are not listed among the arguments that the function takes. And I was like, wait, parameters are not listed among the arguments that the function takes. So it's like, can you explain that a little bit more, Wikipedia? And what they say is that the variable x designates the function's argument, but a, b, and c are parameters. So if we look at this mathematical function here, we see that x is the argument, and a, b, and c are the parameters. I was like, wait, doesn't that mean that x is helping define the function, but it's the argument? So I was really confused. So here you see that a is a parameter, and then in the function, the JavaScript function below, bar is a parameter. It's like, what? That's really wrinkling my brain. So the way I like to explain it is with dogs and footballs. So the dog is a parameter, the football is computer science, and so when parameter hits computer science, it gets totally flipped on its end. So the takeaway here is that parameters help define a function and arguments are passed into a function. So here's the answer. Parameters up at the top, it's helping define the function shark, and then the string left is actually the argument. So all of that being said, we almost always use parameter and argument interchangeably, right? So that was easy. All right, so scope. When people try to get me to talk about scope and explain scope, I'm just like, oh God, please don't make me talk about scope and scoping issues. I hate it. So this is how I feel. But let's talk about lexical scope. So Google says that lexical scoping, sometimes known as static scoping, is a convention used with many programming languages that sets the scope or range of functionality of a variable so that it may only be called or referenced from within the block of code in which it is defined. And you kind of feel like, huh? So you notice in that definition that they say lexical scoping is also called static scoping, scope is also called range of functionality, and then called is also called referenced. And they actually use the term scope to define lexical scope. So before you can even learn what lexical scope is, you need to know what scope is first. So let's break it down a little bit. All right, Online Etymology Dictionary says that scope is aim, purpose, object, being aimed at, mark, or target, which doesn't really help us explain it in computer science. So Wikipedia says that a scope is a part of a program that is or can be the scope for a set of bindings. And then they say that a precise definition is tricky, see below. All right, so let's see what they say below. In computer programming, the scope of a name binding, an association of a name to an entity, such as a variable, is part of a computer program where the binding is valid, where the name can be used to refer to the entity. And I think, again, because we're all programmers here, this definition, it makes sense, but think about being a new person coming into programming. It's kind of confusing still, so I say that this is an okay definition. So I keep reading in the same definition on Wikipedia, and here that they say that the strict definition of lexical scope of a name or identifier is unambiguous. I'm like, okay, thanks for being really condescending, Wikipedia. But then they also say that that it is the portion of source code in which a binding of a name with an entity applies. I'm like, okay, finally, we've got like a one-phrase definition. That's really helpful. But then I keep reading, and I'm like, it's virtually unchanged from its 1960 definition in the specification for ALGOL 60. So I don't know about you all, but I didn't know what ALGOL 60 was. Well, it turns out that it's short for the algorithmic language of 1960. So ALGOL 60 was the first language implementing nested function definitions with lexical scope. So we've had the definition of lexical scope since 1960, and we still can't explain it. All right, so now that we've talked about lexical scope, let's talk a little bit about lexical versus dynamic scope. Wikipedia says that lexical scope is the main focus of this article, with dynamic scope understood by contrast with lexical scope. So again, you need to know what lexical scope is before you can understand what dynamic scope is. Are you guys still with me? Okay, so Online Etymology Dictionary says that lexical means pertaining to words. It's like, okay, that's not really helpful, let's keep going. And then you'll see that dynamic is talking about motion and physics. So you'll see also that it's the opposite of static. And if you remember earlier in the definition from Google, lexical scoping is also called static scoping. So dynamic scope, static scope, lexical scope, they're kind of opposite. So I look up in Wikipedia, let's talk about, lexical versus dynamic scope. And they say that for most programming languages, part of a program refers to the portion of source code or area of text. Again, lexical refers, it said pertaining to words, and they say here area of text, so that's interesting. And that's known as lexical scope. In other languages, however, part of a program refers to a portion of runtime or time period during execution, and that's known as dynamic scope. And then I keep reading, it says, both of these terms are somewhat misleading. They misuse technical terms as discussed in the definition. I'm like, wait, so that definition's wrong? And then I keep reading, and I'm like, but the distinction itself is accurate and precise, and these are the standard respective terms. It's like, wait, that definition was right? So I'm really confused. And then I keep reading, and we see that in practice with lexical scope, variable's definition is resolved by searching its containing block or function. Then, if that fails, searching the outer containing block, and so on. Whereas with dynamic scope, the calling function is searched, then the function which called that calling function, and so on. So that makes more sense, I think. And so again, all that being said, most modern programming languages use lexical scope instead of dynamic scope. So who really cares about dynamic scope, right? So the way I like to explain lexical scope is with cats in boxes. So let's pretend the cats are each variables, they're variables, and the box is a function, and the orange cat can see the white cat, but the white cat can't see the orange cat. So that is lexical scope to me. Okay, next up is recursion. So, Online Etymology Dictionary says that recursion refers to a running backward or to return. And Wikipedia says that the most common application of recursion is in mathematics and computer science, in which it refers to a method of defining functions in which the function being defined is applied with its own definition. And I was like, that's a lot of defining for just one definition. So let's keep reading. We also see that specifically this defines an infinite number of instances using a finite expression that for some instances may refer to other instances, but in such a way that no loop or infinite chain of references can occur. So I keep reading, and then again we see that recursion in mathematics and computer science is a class of objects or methods that exhibit recursive behavior when they can be defined by two properties. Number one, a simple base case or cases, a terminating scenario that does not use recursion to produce an answer, and a set of rules that reduce all other cases towards that base case. And as I said, we're all developers, so this definition of recursion makes sense to us. But again, as a beginner, you read this and you're like, I don't really understand what that means. So I feel a little bit like this when I read that definition. But the way I like to define recursion is by saying that it's just a function that calls itself. And I've heard before from other people that if I say that, then that includes infinite recursion. And I'm like, well, that's still recursion, it's just you're probably doing it wrong. So a lot of people, when they're explaining recursion to me, they bring up the Fibonacci sequence, and I feel a lot like, whatever. I mean, it's been at least a decade since I took any math class, and I don't really remember what the Fibonacci sequence is. So another friend of mine actually explained recursion by talking about factorials, and I think we all like factorials because they have a cute little exclamation point. And it's just kind of a straightforward way of explaining recursion to people because it's something that we learn in probably middle school math. So when I see that definition of recursion using factorials, I feel a lot like this. Yeah, that sounds about right. Okay, next is concatenation. So concatenation means basically a linking together. And I was like, oh, that's exactly what we use concatenation for in computer science. Yes, finally, we got one right. But actually, I just want to talk about this because it's got the word cat in it. And this is my cat. And here's a recursive cat. All right, let's talk about instantiation. So the online etymology dictionary says that instantiate is related to instantiated or instantiation, and it comes from the instant. Google says that instantiate means to represent as or by an instance, and they say, as an example, a study of two groups who seem to instantiate productive aspects of this. I was like, this what? As if this isn't confusing enough in JavaScript. So, to find out what instantiation is, we actually have to go back to philosophy. And you'll see that in predicate logic, universal instantiation, also known as UI, and I was like, oh, UI, I recognize that. That's user interface, right? So it's also called universal specification or universal elimination. And it's also sometimes confused with dictum de omni, but it's a valid rule of inference from a truth about a member of a class of individuals to the truth about a particular individual of that class. And so basically what they're trying to say is that all cats are mammals, Fry is a cat, therefore Fry is a mammal. So that's essentially universal instantiation. So we can explain that also in code. So here you'll see that I have a mammal, I set its neocortex to true, and then I also define cat, and then I give cat the prototype mammal. So all cats are mammals, and then I instantiate a new cat via Fry. So Fry is therefore also a mammal. Cool. Weirdly, the online etymology dictionary actually, instantiation redirects to instantiate, and on Wikipedia, instantiate redirects to instantiation. So I'm not really sure which form of the word is correct. All right, on to acronyms. So CRM, CMS, and CDN. These three always confuse me. So just as a reminder, or for people who don't know, CRM is a customer relationship manager. It's kind of like Salesforce. CMS is a content management system, kind of like WordPress. And a CDN is a content delivery network, kind of like Amazon CloudFront. Okay, SaaS versus SaaS. So please clarify to me, when you're talking about SaaS, which one you're talking about. Are you talking about software as a service, like Salesforce, or are you talking about syntactically awesome style sheets, which is the CSS extension language? Okay, now DOM. So this is Grazer Dom, which is a cathedral in Austria. This is Dom, the American indie band. This is the Dom, which is a mountain in the Pennine Alps, and it's located between Ronda and Saas-Fee. And again, we see that word Saas. So there's lots of different types of DOM. But of course, the one I'm talking about is the document object model. Wikipedia says that the DOM is a cross-platform and language-independent convention for representing and interacting with objects in HTML, XHTML, and XML documents. I'm like, okay, that's kind of helpful, but not really. So let's check out and see what the Mozilla Developers Network has to say. And what they say is that the DOM is a programming interface for HTML, XML, and SVG documents, and it provides a structured representation of the document as a tree, and it defines a way that the structure can be accessed from programs so that they can change the document's structure, style, and content. I'm like, okay, that makes a bit more sense. Thanks, MDN. They also provide this kind of funny diagram. I'm like, oh yeah, that looks kind of like an upside-down tree, so that's helpful. Okay, next up is GUI and CLI. And I like to call it CLI, even though other people say CLI. Because if we call it GUI, why can't we call it CLI? So when I hear GUI, I think of ooey gooey butter cake, and I get really hungry. I also think of gooey ducks, which are bivalves that live in the ocean. And then when I hear CLI, I think of the painter Paul Klee. But again, as we know, I'm talking about the graphical user interface and the command line interface. And as you see, graphical user interfaces were introduced in reaction to the perceived steep learning curve of command line interfaces, which require commands to be typed into a keyboard. All right, next is Ajax. So Ajax stands for Asynchronous JavaScript and XML. But who even uses XML these days, right? And the other thing I've realized with Ajax is that the jQuery method for Ajax actually has an option to run async as false. So you could actually be running sjaj, synchronous, JavaScript, and JSON, right? So that's confusing. Anyways, in conclusion, so with programming concepts, at least for me, a lot of times what happens is you just have no idea what's going on. And then at some point in time, you just get it. And it's really hard to pinpoint when that happened and how it happened. So that makes it really hard to explain these concepts to other people if you can't track back to where you were. So it's hard, I get it. But I implore everyone, if somebody asks you a question, don't be a meanie. Don't be like this. Don't you understand anything? And also don't be like this, ooh, are you asking me that guy or that guy? Because I don't really want to talk to you right now about that. Try to be a little bit more like this. You got it, dude. I'm totally going to explain that to you. I would totally spend the time to answer all of your questions. Because it's really difficult trying to learn programming. So here's a quick video kind of explaining what I'm thinking about. You'll see number 12 has fallen on the ice. She's kind of back here in the corner, and she's like, I don't understand what GUI means. Everyone around me is talking about GUI, and they all know what they're talking about, and I don't know what it means. And then you'll see other number 12, who's on the opposing team, come over, and she's like, let me help you. I will explain what GUI means. GUI is the graphical user interface. And she's like, oh my God, thank you. I finally understand what GUI means, and I can play along with everybody else. So when we're all a little bit more like number 12, then we can party together in the computer science jargon land. Thank you.